Hello guys, welcome once more to another video in our YouTube channel. So in this video we are going to be looking at a proof which is saying that we should prove that 2 to the power n plus 2 plus 3 to the power 2n plus 1 is divisible by 7. So I'm going to use two different methodologies. The first one I'm going to use is proof by mathematical induction, and secondly I'm going to use some concepts of number theory to do that. Alright, so the statement says that 2 to the power n plus 2 plus 3 to the power 2n plus 1 is divisible by 7. So I first of all want us to recall that if you have a number a, if a is divisible by b, then we can say that b actually divides a. Okay, so a is divisible by b, it means that b divides a. So in this case, this number here or this quantity here is divisible by 7. It means 7 can divide this quantity. And if b divides a, we have that a is actually a multiple of b. Okay, so a is equal to b times a certain integer. That's a mathematical definition of the statement b divides a. So if b divides a is a multiple of b. If b divides a, b is a factor of a, and if b divides a, then a is divisible by b. Alright, so in this case we have the statement 2 to the power n plus 2 is divisible by 7. So we are going to convert that statement into something that we can easily use. So 2 to the power n plus 2 plus 3 to the power 2n plus 1 is divisible by 7 if and only if, or let's just say it implies that this quantity here is simply a multiple of 7. So, or 7 is a factor of that quantity. So we can say it is equal to 7k. Alright, and we precise that k is in a set of integers. Alright, so let us now, like I said, we are going to use two different methodologies. So the first method we are going to use is proof by mathematical induction. Proof by induction. Here we start by letting the statement. So we let the statement, all of this, okay, so we have the statement, all of that be maybe p of n. Alright, now in this mathematical induction we have to do four things. Okay, so after letting this to be the statement, the first thing we have to do is that we have to do what we'll call verifying that it is true for the first value of n. Okay, and remember that here our n is simply in the set of natural numbers, so we are just taking positive whole numbers including 0. So the base case is that we have to verify that p1 is true. Okay, now I can maybe let me pose f of n to be equal to this quantity so that we don't rewrite it many times. Okay, let's suppose f of n to be equal to that quantity. So what do we have? If we want to look for the statement p1, or let's say p0 instead, let's say p0. If we want to get the statement p0, it means we have to verify that if we replace n with 0 and replace n with 0 and add up the two quantities we have, the answer will be a multiple of 7. So let's look for f of 0. F of 0 is simply 2 to the power 0 plus 2 plus 3 to the power 0 plus 1. So you verify that you have 7 and 7 is a multiple of 7. Okay, so the statement p1 is p0 is true. Hence we have that. Hence we have p0 is true. Now the second thing we have to do is that we have to assume that it is true for n equal to a certain other integer, let's say r. So we call that step the induction hypothesis, that assumption, the induction hypothesis. So here we have to assume that, hypothesis. So here we have to assume that the statement p of r is true. That is, we have that f of r is a multiple of 7. That's the assumption. Alright, so let us write down what that means. It simply means that all of this, okay, is equal to 7 times r. That's our induction hypothesis. Now the third thing to do is now we do what we call the induction process or the induction step. And in this step, we have to prove that the statement P of R plus 1 is true from the assumption that the statement P of R is true. So you have to prove that P of R plus 1 is true. That is, we actually have to prove that if you replace here we have to replace n with arrow. Okay, our k is still there, so we replace n with arrow. So actually what we have to prove is that if we replace n here with arrow plus 1, okay, and we replace the n here with arrow plus 1, the final result will still be a multiple of 7. Okay, that is what we have to prove. So to prove that, we begin with this with a function f of arrow plus 1. Okay, and we have to prove that f of arrow plus 1 is a multiple of 7 using the assumption that f of arrow is a multiple of 7. So f of arrow plus 1 is simply equal to what we have simplified here. So we just have to simplify. We realize that 1 plus 1 we add up to give us 3, and then if we expand here, we are going to get 2 arrow plus 2, and the 2 will add up to 1 to give us 3. Alright, that is what we have. So from there, we now use the assumption that we have in the induction hypothesis. So look at what we are going to do. So I can just simplify this into, now this is 2 to the arrow times 2 to the power 3, which is the same as 8. Okay, 8 times 2 to the power arrow, then plus, now this is simply 3 to the power 3 times 3 to the power 2 arrow. We can call it 27 times 3 to the power 2 arrow. Alright, now from here, you see from here, in fact we can just come to this step here and we try to look for a certain unknown. Let's just say, now you clearly see that 2 to the power arrow plus 2 is the same as 2 to the power arrow times 2 to the power 2, okay, which is simply 2 to the power arrow times 4. So that quantity is simply equal to 7k minus all of this quantity minus 3 to the power 2 arrow plus 1. Alright, so the 8 which is written here, we can break it down into 4 times 2. Okay, we can break it down into 4 times 2. Now in a place of 2 times, or let me just put the 2 outside and I put a 4 inside. Now in a place of 4 times 2 to the power arrow, I'm going to replace it with all of this quantity. So it means that my f of arrow plus 1 is equal to, now in this I'm just going to copy here, and then in the place of all of this, okay, I'm going to replace it with its identity from the induction hypothesis, since it is true. So the resulting statement here is obviously supposed to be true. So it therefore means that my f of arrow plus 1 is simply equal to, now I'll take 2 times 7, which is 14k, alright, now minus 2, now times 3 raised to the power 2 arrow plus 1, which is, I'm multiplying it again with 3. Okay, now this 3 and 2 multiply to give us 6. So this is just simplification. I'm just simplifying. Now and finally we are going to be left with this quantity, so plus 27 times 3 to the power 2 arrow. Now we can add the like terms together. We have 14k. Now we see that 3 to the power 2 arrow is a common factor, so you have 3 to the power 2 arrow. Now if you actually remove it from here, you'll be left with negative 6 plus 27 is just going to give you positive 21. Okay, so from there we can clearly factorize 7, and we get that our f of arrow plus 1 is equal to 7 times 2k, yeah, 2k plus, now when you factorize 7 from 21, you get 3. When you multiply the 3 with 3 to the power 2 arrow, you simply get 3 to the power 2 arrow plus 1. Alright, that is what we have. But remember that our k is an integer and arrow is also an integer. It therefore means that 3 to the power 2 arrow plus 1 is an integer and 2k is an integer. So adding up 2 integers, you also get an integer. Alright, so we can just say that integer is p. So at the end of the day, we have clearly proving that f of r plus 1 is also a multiple of 7, and this completes the induction process. Alright, so the last thing is our conclusion. Or from here we can just say hence the statement p of r plus 1 is true. Alright, now the conclusion. How do we conclude? Since it is true for n equal to 0 and true for n equal to r plus 1, as assumed or supposed true for n equal to r, then it is true for all n. It is true for all n. It is true for all n in the set of natural numbers that I just need to copy my statement that p of k is true, right? That is that all of this is divisible by 7. That that this is divisible by 7 as proven by mathematical induction. Okay, so we are done with that. Alright, so like I said, the second method we are going to use. Okay guys, please, if you have any difficulty in understanding any step here, do well to ask your question in the comment section. I'll be very glad to respond to you.